Good morning. I'm glad to see the fresh crowd here at 8:30. I know we start early, but we want to cram in as much stuff as we can. And the first one crammed in is Tom Ford, and he will introduce the Grails Infinispan plugin. Go ahead.
Morning, everybody. Thanks for coming to my discussion on the Grails Infinispan plugin. I'm Thomas Fuller, and I'm a limited company contractor based out of London. So I do software development, mainly in Java Enterprise software and some Grails work. I had a contract last summertime that ended, and so I took some time off and started to invest some of that time in learning some technology that I hadn't actually had exposure to in the past, and that technology in particular was Grails. Grails plugins and Infinispan. So I had worked with Grails in the past, but I hadn't done significant work with the plugin architecture. I had an interest in caching architectures such as coherence, gigaspaces, Gemfire, etc. And Infinispan was kind of new on the market, at least to me. It was starting to look kind of interesting. So I decided that I would put the two together and give the people that do Grails development the ability to use Infinispan in their applications. So I'll give you a quick overview of what we're going to talk about. So I'd like to tell you a story, and this story is completely fictitious, and it's kind of like a use case, if you will, for where Infinispan could fit into a project that you may do. Infinispan and other caching architectures are very applicable in the enterprise software development. So what I'm talking about is definitely not limited insofar as applicability is concerned. We'll go on then from the story into discussion of some design principles behind the plugin itself, and then quickly move into some code examples, and give you some ideas, or some examples of how the plugin works and how you can use it. We don't cover it full scope, but I touch on quite a bit of it, and then we'll get into the conclusion from that point on. So let's start with our story, and the story goes like this. We have an e-commerce company. The e-commerce company has sold a product for the past couple of years. It's kind of popular, and their front end of their application looks like a regular web application running on, it could be Java based on JPA or Hibernate. It could have Spring MVC, it could have some front end components as well, like JSF or some other framework that you can use to achieve front end development. Talking to some databases. So the databases are clustered. The front-end application servers, they're clustered as well. And from the past traffic that's come to the site, they've never had any trouble. They've managed to satisfy their customers' desire to purchase products from this business, and everything's been okay. So what went wrong? So what happened was this business has a marketing department, which is quite a good marketing department. They ran a viral marketing campaign, and the product that is kind of popular that this company sold becomes very popular in a very short period of time. So from the chart here, what you see is on this particular day, when this viral marketing campaign just goes crazy, the traffic skyrockets. And the increase in traffic happens in a very short period of time. So from the business's point of view, this is fantastic. The business is selling a product online, and what we have here is customers wanting to spend money. But the problem is that because this happens in such a short period of time, the application servers and databases are overwhelmed. So they can't cope with this problem. Eventually, what will happen is the traffic spike, if it's severe enough, is going to cripple the app servers. People won't be able to purchase the product that they're interested in, and as a result of that, the company is going to lose quite a significant amount of money. But going on from there, we have other side effects. Other side effects such as customers that are upset. We have potentially bad publicity. From the development point of view, people are going to get quite a bit of stress coming down on them from management. So what's going to happen next is it's a failure. So this viral marketing campaign that this business has set up and has turned out to be a massive success is actually going to turn out to hurt this business quite severely. So I'll introduce you to our first developer. This is Dave the developer, and Dave was about to go on holiday. And as you can see, he's not exactly happy. So Dave was just about to walk out of work, maybe he was getting in his car, and the phone rang. And that was his first mistake, was leaving his phone on. Anybody know what the second mistake was? Answering it. So Dave answers his phone and they tell him, come back, you're not going on vacation. You need to deal with this problem, and you need to deal with it right now. So Dave, being the developer that he is, goes back, he looks at his application, and he starts going through code. He starts optimizing, he starts refactoring, he might do some profiling. Peter Ledbrook, in his discussion yesterday on tuning Rails applications, talked about doing optimization too soon, or doing it without profiling. But in this case, Dave is reacting to a situation that's happening right now, so he's doing it too late. Furthermore, doing refactoring and optimization in a scenario like this, it's impossible to achieve the results that you need in the time that you have to work with. This company has traffic going through the roof. They have tons of opportunity. They have the ability to attract new customers. They have, of course, money is something that's very important for the business. So if Dave is called in and told to refactor and optimize, fix this problem, he'll never be able to get this solution turned around in the time that he has. If the business has a robust testing process, if the application has to go through a couple of different layers in the business, for instance, testing, and then they roll it out, they have production people that manage these servers, never happen. It just simply isn't going to work. So let's assume for a moment that Dave is able to do this. And the company has this incredibly powerful marketing department that's able to go out, rerun the same marketing campaign, and get similar results. When we get this traffic spike, so customers come back to the site, want to do shopping again, ultimately Dave's solution isn't going to work anyways. So the traffic spike happens again. We have a very short time period in which the traffic goes through the roof, and ultimately Dave's solution doesn't fulfill the requirements of this business. So, we move on. This is Nate from networking. And Nate sits down, takes a look at the problem, because now this has gone from Dave, this has moved into networking, and they say, take a look at what we have and try to fix this. So Nate goes back and takes a look at the hardware and the machines that the software is running on, and he says, you know what? It's not enough. What the software has been running on isn't powerful enough to support the needs of the business at this point in time. So Nate from Networking Solution is to buy bigger servers. He goes out and he purchases the biggest hardware that his vendor can give him. So maybe he calls Dell, or maybe he calls some company down the road, and he says, I need the most processing power that you have, the most memory, the most hard disk space. I need it, and I need it now. So of course, Nate's solution takes time. You can't just have that delivered right then and there. Generally speaking, if it's a big company that they purchase their hardware from, it's going to take them probably a week, maybe longer, if he's really lucky, to get that hardware. He's going to have to set it up. He's going to have to put the software on it. Ultimately, they're also going to have to pay for it. So what we have here is we have a solution that is specifically needed for a very short instance of time. But what they're doing is they're going out and they're buying hardware, which is then going to be in business from that point forward. So you're not just going to return it to your vendor and say, okay, I'm done with it. So another problem with this solution, it's not economically viable. What do? If this solution doesn't work, do you go and tell management, I need to buy bigger servers? I mean, the ones that we just bought, they were good enough. They got us some more traffic, but ultimately, we need more. It doesn't work. So if we go back and we look at the traffic spike, so again, we need to give me a bit of literary freedom here to tell this story the way it is. The company will go out, they will run their buyer marketing campaign again. The public, being as forgiving as they are in this case, will come back to the site and want to purchase this product again. Traffic will go through the roof. Maybe the business can handle some more traffic. But the problem is that ultimately that will hit the threshold where the hardware and the application simply can't cope with the load that's coming in. And we have a failure. So this solution that they put in place doesn't work. So, management in this business is now going to pass this problem off to Sarah, the senior developer. And Sarah goes back and she sits down and she takes a look at where the application is at this point. She talks to Nate from networking. And she does some homework. And after conferring with Nate, she says, okay, bigger hardware, larger servers, larger database servers, it didn't help us. But what might help us in this case is replicating the servers. So it actually seems like a reasonable solution. If 2 servers couldn't fix this problem, we'll add 3 or 4. And this particular approach to this solution, or to this problem, won't work. And the problem that Sarah's facing is that we look at hardware, we say we need to put the hardware in place, the purchasing, the installation of software, the deployment of the hardware didn't work. But in this case, we have a similar situation. We need to set up these machines, we need to put the software on them, we need to deploy them for purposes of if the software on here is proprietary software, such as Oracle or IBM, you need to get the licenses for it, which means you need to spend money. And if you're spending money on that, what are you going to do when the solution, or when the problem that we've been talking about starts to subsist? So the traffic spike happens, the sale that this business has been running, the buyer marketing campaign, results in traffic. Traffic is only there for a limited period of time. After that, traffic starts to go away and the business starts to experience what would be normal traffic. We're stuck with extra software, extra hardware, and ultimately the solution that doesn't fulfill the needs of business. Now, I've just touched on the business concerns. From a technical point of view, this solution won't work either. So even if the business could deploy this in a heartbeat, the problem is that from a technical point of view, it won't work. So take a look at the application servers for a minute. We have 3 application servers here. If we have session information and application information in those application servers and they're replicated, as that traffic spike goes up and up and up and up, we have session information which is going to be copied around between these app servers. We have another problem. So let's say, for instance, that we don't want to replicate in memory. We want to replicate by using the database. So we can say, okay, replicate sessions. So we will take the session information and we will leave the responsibility of managing that up to the database. So if there's a user that's routed to the bottom machine and they get routed to the top machine by a load balancer, for instance, when their session's not available, it's going to retrieve it from the database. That presents a problem as well, because if sessions change, they have to be persistent to the database. So if we have an enormous amount of traffic overwhelming the system, what will happen is the database will quickly become the bottleneck. So we've looked at, throughout this entire discussion, we've focused on two things in particular that the solutions offered won't work. They won't work for business purposes, and they won't work for technical purposes. This particular solution leaves us in the same position as the other two. The business goes out, they run this marketing campaign. The marketing campaign results in traffic. Traffic results in the same thing that we've seen so far. The application as a whole won't be able to handle this, given a solution where we replicate servers for the purposes of adding in linear scalability, high performance, and fault tolerance. So that's really what we need here. We need those three things, and they won't be achieved with this solution. So that's a failure. So, we'll do a quick recap where we're at the moment. We looked at three possible scenarios where we try to solve this problem. Optimization, refactoring, it won't work. It's too low level. Larger servers, it won't work. It's not economically viable. Can't be deployed quick enough. Ultimately, if the traffic spike is severe enough, from a technical point of view, it won't work. And finally, we look at scaling app servers and databases. Technically, it won't work. And from a business point of view, it's quite expensive. Quite expensive solution for a problem which lasts for a very short amount of time. So, I'd like to introduce you to Art, the architect. So Art goes back, he takes a look at this problem, he reviews it, he does some homework, and he comes up with a solution that will work. And in this case, this is where Infinispan fits in. So Infinispan is a caching architecture. In this particular example, it fits in between the app servers and the databases. And it's going to deliver to the business what this business requires. It's going to give the business a solution which allows it to act proactively, so it will know in advance of this traffic spike happening that in the event that it does happen, they can deal with it. So they won't be caught flat-footed and reacting to the scenario. It'll deliver fault tolerance, it'll deliver scalability, and it'll deliver high performance to the application as a whole. So, Infinispan is a shared memory data grid. It fits right in the middle here. And the way that it'll help this application deal with this problem is that traffic is being directed to the app servers. The load balancer is in front. I don't have the load balancer picture here, but just imagine that there's one there. And if you imagine that we're using something like JPA, or even if this is a Grails application and we're going through GORM, we can install Hibernate as a second level cache. And when you make a call to the database, normally you just ask Hibernate for the data and it'll go to the database. It'll get that data back and then you can use it. The problem is though is that if you take a moment to consider all the work that has to go on between the app server and the database. It makes a call for data. The database will check, do I have it in cache? If I don't have it in cache, I have to go to disk. I get this information back. Send it over to wire to the application server, which it's not in a format that the app server can use right away. It needs to be transformed into a Java object. Once it's in the form of a Java object, then you can use it. So in that particular scenario, there's actually quite a bit of effort involved. Well, what Infinispan is giving you is a cache. So very similar to what you'd see in a map from java.util.map. You make a call using a key, so it's really fast, and what it's giving you back is a serialized Java object. So the app server can work with it right away. No conversion is necessary, and the data is also replicated. So you'll have copies of the data floating around the grid, and if one of the nodes in the grid were to go down, the copy would be promoted to a primary, and then it would be copied again, so you don't experience a user experience, a degradation of user experience. The caches are quite smart, so they can evict information when the information is not being used. And there are several algorithms and choices that you have available for how you'd like to do that, or how you can achieve that. The caches are quite intelligent, so if I add caches on, if I add extra nodes, the amount of memory that we have to work with overall will expand. If we replicate session information, we can replicate it on the cache. There's a caveat to that. I'd like to mention a caveat right now because I usually forget when I'm practicing this. And the caveat is that at this point in time, JBoss doesn't have the implementation for session replication yet available, but it is coming. It's coming in, I think, this year sometime. Anyways, you will be able to replicate sessions on the grid, so I'll talk about that for a moment. So sessions, we could replicate between app servers, and we know what the problem is there. We have enough session information in memory. Eventually, garbage collector thread kicks in, the app server will start to slow down as it deals with this massive amount of memory that's being used up. But in this case, what we can do is we can replicate session information on the grid. So what will happen is, we don't need to put it in the other app server. If the load balancer were to direct a customer from one app server to another, the app server would say, do I have a session for this user? No, I don't have a session, so I'll check the grid. Okay, this session is in the grid, so I can use it. So we've covered some of the fault tolerance, we've covered some of the high performance. We talked briefly about the scalability. The business, in this case, has this massive traffic spike. Short period of time, they need to react now. What can you do? You can add on extra nodes. So, I'll give you a quick overview of Infinispan. Infinispan is a JBoss product that's based in part on code from JBoss Cache, but it gives you a lot more. And it's very powerful software. It's licensed under the GPL, so you don't have to provide any upfront licensing fees to use it. You can download it. You can get started right now. It's a distributed in-memory data grid, and it has competition. Coherence, Gemfire, Gigaspaces, Tibco has an implementation of this, IBM Extreme Scale. So there are other competitors out there with similar offerings and functionality, target business needs slightly differently in some cases. And as of May of this year, Red Hat offers support for Infinispan. So it is a product that has a big name backing it. So in this case, we go back to our scenario that we've talked about so far. The business runs a marketing campaign. The marketing campaign results in a massive amount of traffic coming to the business quite quickly. And in this case, traffic goes through the roof, and the business is okay. The business knows that when this scenario happens, they can extend the grid. So you have the network that the application is working on, and the business has a need now to extend the grid. It's an emergency situation. So we fire off a bunch of Infinispan caches. We grow the size of the grid. We grow the memory that the application as a whole has the ability to work with. It lasts for a couple hours, a couple of days. Traffic starts to decrease. We don't need those nodes anymore. So we just shrink the grid. So we have a solution that's delivering fault tolerance, high performance, linear scalability to our web applications. It allows us to operate in a proactive manner instead of reacting to a situation. And in this case, it does it with no upfront licensing fees. And if you need support, you can get support from Red Hat. So at this point, we're going to transition and start talking about the plugin itself. So I'll just quickly give you an overview of some of the design principles of this plugin. To be quite honest with you, it's just generally decent engineering practices. So we aim to help developers work with Rails and Groovy naturally. So that means using closures, using mixins. We help you avoid and diagnose problems quickly. So in the case of exceptions, we try to give you quite a bit of information to work with so that if you do see something, you will know, I need to do certain things in order to fix this problem. You're not sitting there guessing about it. avoiding problems, I'll have to give you some examples of that, because there are some nuances with Infinispan that either as a result of the version that it's at or as a result of the way it's been architected, I think can make people's lives a tiny bit difficult. And I've taken some measures to try to actually address that with the plugin. And ultimately, this will help save you some time. So the plugin's been written, it's been tested quite heavily, quite well documented. We have internal documentation at the code level, which is quite good. We have external documentation at a very high level to help you get started quickly. And since you don't have to do this yourself and it's available, you can go ahead and use it and hopefully benefit from the ability to use Infinispan in Grails. So here's an example of the DSL that we use to configure Infinispan. So if you are, if you want to use Infinispan via Grails, and just go to the command line, type in Grails install plugin Infinispan. It'll download everything that you need, and then the next step from there is you need to configure it. And in this case, what we do is we register a bunch of Infinispan objects as beans with strings. And if you read this out loud, it reads like kind of like a regular English sentence. Register cache manager, named matrix cache manager. It's configured externally. In this case, we'll give it a file. So for most of what you do in Infinispan, the configuration is determined by file or by programmatically, but the API is pretty much the same from that point on. So sorry, stepping back. Configured externally, we give it a path to a file, and then we have two caches in this case. We have agent cache and the city's cache. We have a query helper. This is specific to Infinispan 4, and it will go away in Infinispan 5. But for the purposes of this discussion, I'm talking about Infinispan 4 because Infinispan 5 is not yet ready for production. I'm ready for production, but Infinispan 5 isn't. So what will happen is when we get to Infinispan 5 and it goes to GA, I'll promote the software that I have, and then from that point on, if you want to use Infinispan 5, you can. So anyways, meantime, we have Query Helper. Query Helper is used for querying the cache, and it's named Agent Query Helper. It's referencing the agent cache, and it has some properties and some classes. And the classes in particular are the types of classes that we want to query. So I talked about the plugin helping you avoid some problems, and one of the problems that you can get in Infinispan is that if you register a query helper with the cache after you've put objects in it, it will give you 0 results back, and I don't like that. So in this case, we made it part of the DSL, and we have, I think, 4 beans here that we've configured with the app. We have the cache manager, so matrix cache manager. We have 2 caches, agent cache and cities cache, and we have a query helper which is named agent query helper. So these are all beans now that your application can use. Sorry, I skipped the slide. So this is just an example here. If you wanted to configure Infinispan declaratively, you can do that right in the script. Instead of saying configured externally, you just say configured declaratively, and you reference, in this case, we have a global configuration and a configuration. And what you would have to do in this case is you'd have to, prior to this code, you would have to actually declare that and configure it as you would like. So now, I've talked about we registered some beans with the Grails app. If you wanted to use the agent cache, all you need to do is declare that, in this case, in the controller, as I have the example here, define agent cache at the top, and that's it. The reference is given to you. We've added extra methods to some of the Infinispan API. So in this case, transactionally is one of those methods. It takes a closure. So if you want to do some operation on cache transactionally, all you need to do is reference it this way. You don't have to import anything. You don't have to reference the advanced cache. We pass in the transaction manager when the closure is called. So if you need to access it and inspect it in some way, it's there for you. So it helps you save a bit of time. In this case, we've added on another method to the cache, and this is called query. So you can do the query right on the cache in Grails. And when you get back a cache query result, there's in each method, several variants of each actually, to help you iterate through the results that are given to you. So here's another area where we actually have made an effort to try to save you a bit of a headache. With Infinispan, there are listeners that can be added to your cache manager, and there are listeners that can be added to your cache. The thing that I don't like is that if you were to annotate your class with a listener that applied to the cache, and then register that with the cache manager, Infinispan will just ignore it. So what I did is I added on a bunch of methods there to help you use closures, first of all, as listeners. So you can write a closure and attach it to either the cache or the cache manager. You can also remove it if you need to. And I've done it in such a way that you can't make that mistake. So there are methods on there when you register your closure with Infinispan, you'll know exactly what it applies to. So that was my quick overview of the plugin code. We'll cover some food for thought here. Infinispan 5 is currently under development and is going to introduce fork join and map reduce functionality with the API. So that should be very powerful. It should lead to some very interesting applications. Infinispan can reduce the cost for any data source. And we'll talk about a few examples in a moment. But we've talked about putting Infinispan in between the app server and the database, but it could be between the app server and a web service call. There are other examples that you may think of. And Infinispan can be especially useful in the cloud and in service-oriented architectures. So we've talked about this application so far, consisting of 2 app servers, 2 databases, and that's very basic. But for the purposes of this business, it may not be all that you see. So this business actually could be quite a big company. It could be a company that has a very robust IT infrastructure. And let's say, for example, that infrastructure looks something like this. So we've talked about the front-end part of this application, which is in the middle on the left side, so far. But behind the scenes, maybe there's a lot more going on. And it becomes more important in this scenario that everything be fault tolerant, linearly scalable, highly performant. And in this case, I'm just going to give you 3 points before we wrap up the discussion. We have our application there on the left, and it talks to this customer information application. Customer information application is the only part of this business's IT infrastructure which hasn't been modernized. It's running on a legacy mainframe that have maybe 15, 20 years of information sitting on it. It works relatively well, but the resources are very difficult to find to fix it if it falls over. It takes quite a while, and the business really can't push it too hard. So in this case, how can Infinispan help you? You could put Infinispan between the application and calls to this resource. So when I ask for customer information, because this application was written maybe 15 years ago, they could be doing just a regular network call, getting some information back, and then converting it into a Java object. So what we could do is we could prevent unnecessary calls to that application by putting Infinispan in there saying, check the cache first. If the user is there, use it. If it's not there, then make the call to our legacy mainframe application. That way you limit traffic to the application, and it's only doing things that are absolutely necessary, and that's giving back customer information that's not currently available in the cache. Our second example of this, we've talked about saving unnecessary read operations for most of this discussion. But you can do the reverse. You can actually save the application from doing writes every time a write is actually required. So in our case, we have this order processing application, which is in the middle of the screen. And it talks to order history application. So every time somebody orders something, it's going to send a message over to the order history application, which is going to say, okay, write that message into the database. Well, if we have a peak in traffic, so this spike in traffic happens, what we could do in that case is we could say, okay, we're going to configure Infinispan. Obviously, you do this before this happened, but what you can do with Infinispan is you configure asynchronous write behind, and then what that'll help you do is spread out the writes over a period of time. So they'll queue up. There's a background thread in Infinispan that'll take care of writing that information to the database for you. Finally, the last possible scenario that we might be able to use Infinispan here is between our order processing application and what's not shown here, and that is the bank itself. So if we assume for a moment that the application will make a call to the bank and say, okay, here's a web service call, and we're going to request payment, or we're going to request that you make a payment. And in this case, if a customer refreshes their browser and asks for payment status update, either knowingly or inadvertently they make this call. What we don't want happening is we don't want that call going all the way to the bank. Let's just say for the sake of argument that the bank says, okay, we have to limit traffic to our site as well because we have a lot of customers that we deal with. If you make a call for any kind of payment status update, if you do it more than once a minute, we're going to charge you some money for that. That's not ideal for this business. So what we can do is we can put Infinispan in between there. And we can say, okay, we're going to put an expiry on that data that's in that cache. We're going to set it to every minute so that it'll flush out, it'll evict that information from the cache. And then what will happen is the users on the browser, they maybe make a refresh call and they say, okay, tell me what my payment status is. It goes to the cache first. If the information is there, it gets it, it gives it back to the user. If it's not there, it'll make the call to the bank. But you'll know that you won't be charged for this. The business at least won't be charged for this because the cache will prevent that from happening more than once a minute. So I think that at that point, we can start to wrap the discussion up and say that we've looked at 3 attempts that have failed to deliver a solution that could actually solve this problem. We've had business concerns and technical concerns in each of these scenarios. We have looked at the design principles of the plugin. We've reviewed some of the code, and with respect to the plugin itself, I've made a great effort at having it documented at a high level to get you started quickly. We have internal coding and very robust testing. And there's documentation available there. There's a Twitter feed in the event that you use the plugin and you want to come back and either complain about something or offer some suggestions for improvements. I'd be very happy to hear from you. And that's it. So we'll take some questions if you like. Yes, sir.
How do the objects replicate directly on change or on one node, for example?
You mean when you put an object into the cache?
Yeah.
Yeah. So with Infinispan, you'll say, okay, I need a number of copies around. So, for instance, for fault tolerance purposes, let's say, for example, that you made a copy, one copy. So you put an object into the cache, and it'll be replicated somewhere else. It won't be on the same cache, it'll be elsewhere. And so, okay, let's say that somebody says, okay, that's not enough. I'm not satisfied with that. It's not redundant enough for me. Okay, well, set number of copies to 2, and then it'll make it elsewhere. So, I mean, there comes a point when it's a bit ridiculous. Like, you wouldn't want to say I want 10 copies. I mean, that's like a bit out of hand. But 2 or 3, I think is certainly reasonable.
So, and also is the changes on the, for example, on the cache object, is it replicated on like attribute level? Set a name, for example, just the name is replicated, or is the whole object?
That's a good question. I cannot give you a perfect answer on that. I mean, either way you look at it, if you change something in that object, that change will be replicated elsewhere. So if it does it on a granular level, so for instance you change a property, I suspect it might be copying the object itself. The thing is that I'm not that familiar with the internals of how it does it. So if you like, I can try to get you an answer. Give me your email and I'll try to get you something much more definite. Sir?
You talked about running the whole thing. There's some JBoss application serving necessary, right? Or does it run with plain Tomcat?
No. You can run this. You don't even need a JBoss app server. Like currently at the moment, currently I'm looking at integrating Infinispan with Griffin. So there is a plugin project available right now. And there's no code there because I set it up probably about a week ago. But that's one of the steps I'd like to take. Because maybe there'll be somebody there that says, okay, I want to do something with the grid, but I want to do it from a desktop app. I don't want to do it in a web app. You know, I'd like to be able to give that that capability as well. Especially since the two projects are very similar. Quite a bit of the code that I've done can just be ported over to the other one. So yeah, you don't need JBoss App Store for that. In fact, with respect to other implementations, so for instance, Gigaspaces or Coherence, they're going to offer you the ability to swap out the cache replication capabilities on the app servers for like a whole series of app servers. So, but at this point in time, what I think JBoss's next step is allowing you to do that in the JBoss app server. So aside from that one specific piece of code, the rest of it can be used pretty much anywhere. Yeah.
So if you add a node, for example, that maybe runtime, how is that detected by the system?
There's quite a bit of the JBoss code under the hood, JBoss cache code under the hood. I'm not exactly sure how it's doing it. I think that they use peer-to-peer replication or peer-to-peer configuration or whatever. But you know, when you put it, the cache, you create a new instance of it, they detect each other. So they say, okay, I'm here, and then the grid will start to grow that way. So it's quite intelligent. Like, this is the type of software you wouldn't write over a weekend. It requires quite a bit of, I think, research and understanding what it takes to actually achieve all of these three things. That being the fault tolerance, performance, and scalability. Anybody else? Yes, sir.
This example with a user database, how do the cache know if you are changing something in the user database?
Well, I've discussed, like for instance, if you use it in Grails, we have hibernating Grails, and you can set it up as a L2 cache. So what will happen is you request, you want to read information. It'll check the cache first and then go to the database. Now let's say that you change something. That information that's in the cache, see how I can word this. It will take care of that as well. So what will happen is when you do the write-through, that information that's in the cache becomes, I believe, stale. And the next time that there's a read, it'll be refreshed.
But then the change has to go through the cache.
Oh, it does, yeah. If you're going to send it to the database, there's no way of avoiding that. It is going to go right to the database, unless you do async write behind. And then you've got a scenario where, okay, I want to update something. The background thread on Infinispan will take care of sending that to the database.
Otherwise, you have a timer there's a way to put a timeline on the cache.
Timeline for purposes. Sorry?
There's a expiration. Yeah, expiration.
Okay, but there is quite a few
Put
areas.
that in the database, I have another application that are running the user base, but not the one you are using. The user information. So maybe you don't know it's on your application point.
Sorry, forgive me for asking you this. Could you say just one more time what the scenario is?
If you have a user database that are run by another application, not your own.
Yeah.
So it will not go through the cache, the changes.
So so if I go back to this slide, sorry guys. Sorry. So you're talking about what in between here and there?
The customer information.
Yeah.
the information in customer database on this one could be changed by another application, not your front end application.
Yeah.
It could be run by something internal, other application that would change the user.
Yeah. That's actually kind of, I think in that particular scenario, you could run into trouble. Like you wouldn't want to have the cache there and then have some other application not going through the cache and then just changing that data, because you'll end up in a situation where you've got something in the cache that's inconsistent and you don't know that it's actually changed on the database. So I think Peter actually mentioned something like that yesterday. If you do this, you have to make sure that you can account for that scenario. So you wouldn't want somebody coming in, for instance, like an administrator or something like this, going into the mainframe in this case and saying, okay, I'm going to change this guy's home address or something like that. Because unless you can update on your cache and say, look, like that data is no longer valid, you definitely have a problem there. And eventually maybe it'll correct itself, but the problem is that you really would want to say, okay, if I make a change like that, I need to account for that in the cache as well. Otherwise, you know, the package that this person asked to be delivered is going to end up in, you know, Copenhagen, whereas they wanted it in London.
With this solution, aren't you just moving the problem from one layer to the other? Because these nodes still run in your two machines that you have. So eventually it will run out of resources and you still have to buy some other machines to run your nodes in.
That's actually, I think that might be misleading. If we go back a slide. So we talk about this, right? So you're talking that these nodes run in the same application server.
Yeah.
That's not the case. These can run on the network in general. So you create an instance of an Infinispan cache anywhere on your network. And it'll find the other caches. And then they'll form a cohesive unit of basically memory that you have to work with. So that's not actually necessarily running in the app server. You know, you could have, for instance, a VMware instance, or sorry, a copy of an operating system that you can run in VMware that has, you know, maybe 10 or 20 instances of an Infinispan cache. And okay, so now we have a problem. Okay, well, we create an instance of that. Those caches, you know, will find the other ones that are on that network. So now you can react quite quickly. For instance, if we had that happen in our business and we needed computers, we could take copies of computers, or sorry, we could take computers, add them onto the network, put Infinispan software on there, run the caches, grow the grid. Now when we're done with the scenario where we have that peak in traffic, it goes away, just take them off the network and you're okay. So there's definitely not running in the app server. I mean, you can do that, but you run it on the same network and they'll all come together and extend the amount of memory overall that your app can work with.
So in all the computers, the desktop computers from the marketing department being responsible for the viral campaign, taking them into the grid while this is going on, right?
Yeah, exactly. Yeah.
Well, alternatively, you could have the client running on all the Infinispan servers running on all the desktop clients all over the company. They don't use any, they are all idle all the time anyway. Think of the enormous amount of power standing on the desktops.
Sorry.
What kind of monitoring applications are rated in Infinispan? Watching how much of the cache and how many cache hits or
You can use JMX, and you can use that, it's called JBoss Operations Network. I've not actually had my hands on that software, though, so I can't tell you exactly what it looks like and all the capabilities that it offers.
Okay. Well, Tom, thank you for coming and introducing us to Infinispan.
Thank you. Thank you.
And thank you for coming to the